Ancient tech that should not exist. The impossible discovery. The team's lights hit metal first, cold, unblemished, impossibly smooth. Not stone, not relic, metal. 5 meters under desert rock, an archaeologist brushed away sand from what looked like a precision machine cylinder and froze. No corrosion, no tool marks. Carbon dating 4,000 years old. One scientist whispered, "This shouldn't exist. Modern tools couldn't have made this." Every flashlight beam slowed. The air felt heavier, like even time didn't want to move. The moment didn't just reveal an artifact, it cracked open a certainty. Somewhere out there, history had lied. Within hours, photos hit encrypted academic channels. The object was forged from an alloy so pure that even 21st century refineries would struggle to replicate it. Its edges met at tolerances measured in micrometers. Engineers said the machining rivaled aerospace manufacturing, yet the surrounding deposits placed it firmly in the Bronze Age strata. How could that be? To understand why this moment was so unnerving, you need to know something about archaeology. Anomalies make people uncomfortable. Every field thrives on order, one discovery stacking neatly on top of another. Then something small like this shows up and starts rewriting the rules. Suddenly, impossible becomes a word everyone whispers but nobody wants to define. So what if the past wasn't as primitive as we've been led to believe? What if genius didn't evolve slowly, but flared, vanished, and resurfaced again, leaving clues like this? That cylinder wasn't an artifact, it was a message. A technological ghost whispering from deep time, "We were smarter than you think, and maybe than you still are." The first suspicion was contamination. Maybe it had fallen from a modern machine. But every detail, the layering of sediment, the fossil pollen nearby, validated its antiquity. Scientists double-checked their instruments, recalibrated the dating, reran the spectroscopy. Same result, the artifact was ancient, the technology was not. Researchers argued for months. Some swore it was proof of lost metallurgy. Others said it was an instrument part from a forgotten experimental dig. But one problem remained: nobody could find any explanation that made mechanical sense for the era. No blast furnaces, no precision lathes, and yet somehow the impossible object existed. Look closely at the timeline of human craft and cracks begin to appear, pyramids aligned to celestial precision, blocks fitted tighter than modern laser cuts, cities with plumbing systems rivaling contemporary sustainability models, evidence of astronomical computations built long before recorded mathematics. We label them coincidences, but how many coincidences add up to a pattern? Think about it: if even one ancient artifact demonstrates knowledge ahead of its supposed time, then history isn't linear. It's cyclical. Knowledge blooms, vanishes, and reemerges in fragments. The cylinder in the desert is one piece of a much larger puzzle scattered across oceans, stone, and myth. Ancient navigation techniques that mapped stars before compasses existed. Hydraulic systems that delivered water through mountains without pumps. Temples tuned to sound waves that could alter how a human body felt reality. Materials with molecular structures modern chemists still call impossible. Every fragment whispers the same uneasy truth. Someone somewhere once understood the world far better than we do and left breadcrumbs for us to follow. What's more unsettling isn't just the sophistication of their creations. It's that we keep finding them in different corners of the planet, isolated by oceans, cultures, and millennia, yet united by an eerily similar mastery of physics, geometry, and design. Did these civilizations share a hidden lineage of knowledge? Or did human intelligence independently rediscover the same laws again and again, only to lose them each time? Modern researchers disagree, but here's the truth. Until someone explains how artifacts like that cylinder exist, every timeline we trust remains suspect. The deeper we dig, the louder the contradiction becomes. So tonight, we go looking for those contradictions. The technologies that shouldn't exist, the flashes of knowledge that break the timeline, the ideas too advanced for their tombstones. Because either our whole story of progress is wrong or someone somewhere hit the reset button and we forgot what we once knew. Forgotten oceans, ancient navigation before maps. The ocean has always been humanity's greatest mirror, showing us not just our curiosity but our courage. Now imagine this: 35,000 years ago, before cities, before writing, before anyone had even thought about the idea of a compass, people on a small island in the Philippines were already mastering it. On Mindoro Island, archaeologists have unearthed fishing hooks carved from bone so fine they could catch tuna in the open sea. There are obsidian fragments, volcanic glass not found anywhere locally, proof of trade with islands hundreds of kilometers away. Here's the problem: the channels between those islands aren't calm lagoons. They're deep seas filled with unpredictable currents. To cross them, you need more than luck, you need navigation. The evidence says these people weren't just paddling around, they were voyaging deliberately, repeatedly, and successfully. They knew where they were going, and that suggests something else: star knowledge. The same kind of knowledge we don't see written down until thousands of years later. Now take that in. 35 millennia before the earliest known civilizations, humans were already masters of what we now call maritime logistics. To even attempt those journeys, they had to read the winds, understand tides, memorize shifting constellations. And what's wild is that this was long before we thought humans even wanted to leave sight of land. For decades, archaeology insisted that early humans hugged coastlines, afraid of the horizon. But Mindoro upended that story. These people lived because they crossed it. And while the Philippines pushed back our timeline of seafaring, another ancient world was crafting an entirely different kind of ocean science. One written not in journals, but in stone palaces aligned with the night sky. Crete, home of the Minoans. Around 260 BCE, long before compass roses appeared on maps, the Minoans built structures whose foundations pointed to specific stars: Spica, Arcturus, Sirius. Their city-states thrived off trade routes that stretched across the Aegean and beyond, weaving the Mediterranean together long before Greece, Rome, or Carthage. What's eerie is how systematic their celestial orientation was. The Palace of Knossos isn't pointed toward sunrise or sunset. It's angled to mark the heliacal rising of Spica, the harvest star. That's not decorative, that's geometry applied to navigation. The same mathematical principles sailors used millennia later mapped into walls and corridors. When you look closely, the palace reads like a stone compass, a terrestrial guidebook for navigating by the heavens. Ancient sailors didn't just watch the stars, they recorded them in architecture. Some researchers argue that Minoan priests doubled as astronomer-navigators, using temple alignments to train seafarers. Imagine a school of navigation without sextants or maps, operating entirely through ritual observation. They saw patterns where we see chaos, and from those patterns they moved empires. Meanwhile, on another edge of the world, another seafaring miracle was unfolding. The first Americans weren't walking across some frozen land bridge, at least not all of them. Archaeological digs on the Channel Islands off California reveal something stunning: settlements from over 15,000 years ago. These islands were never connected to the mainland. The only way there was by boat, so they didn't just arrive by accident. They had vessels capable of long coastal travel, boats we've never found, but whose existence we can't deny. Now think about what that means for human history. The first Americans might have reached the continent by sea, not by foot. That's a rewrite of one of our oldest migration stories. It means that navigation wasn't an invention of the Bronze Age, it was the birthright of humanity itself. Even the first explorers of the Americas carried maps, not on paper but in memory. Every island chain studied: Philippines, Indonesia, Melanesia, tells the same story: people moving through water when they weren't supposed to. Why? Because the seas weren't barriers, they were highways. Oceans connected, not separated. They were communication lines long before satellites. Let's fast forward to perhaps the most elite navigators humanity has ever produced: the Polynesians. Long before Europeans dared to cross open oceans, Polynesian navigators sailed thousands of miles across the Pacific, guided only by the sky and the sea. From tiny coral atolls, they reached Hawaii, Rapa Nui, even New Zealand, places separated by entire oceans. Modern sailors in steel ships armed with GPS still struggled to equal the accuracy of their routes. They had no compasses, no magnetic tools, no written charts, yet they crossed distances equal to sailing from Africa to South America and back. How? By reading the world itself. They watched the stars rise and set, memorized the subtle bend of ocean swells, noted the color of the horizon, and tracked birds as living signposts. Their minds were maps. A master wayfinder could hold the entire geometry of the ocean in their memory. Hundreds of star paths, seasonal shifts, migratory cues. It wasn't guessing. It was calculation woven into intuition. Modern experiments with reconstructed double-hulled canoes proved it. When trained navigators sailed from Tahiti to Hawaii using only traditional methods, they arrived within a few miles of their target. Thousands of kilometers, zero instruments, pinpoint accuracy. It makes you wonder what else they knew, what knowledge flowed through oral traditions we didn't bother to record. Navigation wasn't just a means of movement. It was a philosophy, a belief that everything was connected by patterns. The sky, the currents, the creatures, all parts of the same code. Lose one piece of that code and the system collapses. Which might explain why so much of that knowledge eventually vanished, not because it was primitive, but because it was fragile. When colonial powers arrived, they brought new tools: compasses, charts, clockwork. The old ways were dismissed as superstition. But in truth, they were forms of cognitive mapping beyond anything modern instruments replicate. A Polynesian wayfinder didn't look for stars, they became part of their rhythm. Across epochs, the same intelligence appears. The Minoan stargazers, the Philippine islanders, the American voyagers, the Polynesian navigators. Separated by oceans, united by one astonishing trait: humans who read the planet like an open book. This is what advanced technology looked like before metal and electricity: applied memory, embodied geometry, environmental code. An algorithm of survival written in wind and wave. So when skeptics laugh at theories of ancient advanced science, they often overlook this: there's more than one kind of technology. What's a GPS if not a modern retelling of what Polynesians already knew, that everything follows a pattern, and if you listen, nature will tell you where you are. We keep finding the same fingerprints in different times and places. Stone walls marking solstices, trade goods moving between continents before maps existed, stars charted with near-modern precision. Maybe the bigger mystery isn't how they did it. Maybe it's why we stopped. Because think about it, these were people without electricity, without written science, but with an awareness of the world we can barely fathom. Every voyage was a data experiment, every return trip a proof of concept. When you look at it that way, maybe they weren't early versions of us. Maybe we're the forgetful descendants of them. The story of navigation isn't the story of how humans conquered the sea. It's the story of how we learned to sync our minds with the planet and then forgot how. They crossed oceans without compasses, mapped stars before telescopes, and built mental machines to store their knowledge. And somehow, that might have been their greatest invention of all. Because if ancient mariners could navigate entire oceans using nothing but sky and memory, then maybe the real technology we lost wasn't made of bronze or stone. It was the mind's ability to think in constellations. And as incredible as that mastery was, it's only the beginning. Water didn't just carry their ships, it fueled their civilizations. Some controlled it so precisely they turned deserts into gardens and mountains into fountains. Their oceans were their highways, but their rivers their power lines. And that's where we go next, straight into the veins of Earth itself, where entire civilizations engineered miracles we still can't replicate. If you think seas were their highways, wait until you see their rivers. Water from stone, the lost science of ancient hydraulics. Water, it's the simplest element to us now, something that flows when we turn a handle, but in the ancient world, water was the measure of civilization. Whoever could control it, survive drought, and keep a city clean had power equal to kings. And somehow, without turbines or electricity, ancient engineers built systems that still hum quietly, perfectly functional thousands of years later. This isn't just plumbing, it's genius carved into rock. Let's start underground in Persia, where the earth itself was made to breathe water. The Persians built Qanats, vast networks of sloping tunnels designed to capture groundwater and bring it miles to the surface. No pumps, no mechanical machinery, just gravity and precision. Imagine you're cutting into mountain stone with Bronze Age tools. Your tunnel has to descend at exactly the right angle, not too steep or it will collapse, not too flat or the water won't move. Each Qanat stretched for kilometers, threaded with ventilation shafts so that air pressure could balance and moisture wouldn't evaporate. Many still flow today, quietly feeding villages under blistering deserts. Think about that, a technology over 3,000 years old still functional while our modern pipes rust out in decades. It sounds simple, but the math behind it was maintaining a constant gradient across dozens of kilometers without crossing tunnels or losing altitude too fast required astonishing surveying skill. Geologists examining preserved Qanats found that their slopes stayed true within centimeters over entire lengths. No theodolites, no lasers, just experience, geometry, and intuition honed by generations of trial. In many ways, Qanats were the first sustainable infrastructure, zero energy, zero emissions, perpetual flow. What we now call green technology, they called survival. Meanwhile, further west in Mesopotamia, the Assyrians were building monuments to hydraulics so massive they made the Roman aqueducts look like apprentices' work. The Jerwan Aqueduct, commissioned in the 7th century BCE under King Sennacherib, carried water over dry valleys into the gardens and palaces of Nineveh. Its stones, over 440,000 of them, were cut and placed with such uniformity that the gradient barely wavered. 9 meters tall, 22 meters wide, and almost 300 meters long, this aqueduct used an engineering principle we rediscovered much later: hydrodynamic stability through precise flow control. Inscribed blocks bear cuneiform warnings. Whoever damages this work, may his name be erased by the waters. Brutal poetry for a masterpiece of mathematics. Archaeologists studying Jerwan have confirmed details that still puzzle engineers. The joints show waterproofing methods akin to hydraulic cement. The channels use calibrated width reductions to maintain pressure. In short, they built a working pressurized water system before Archimedes formalized the laws governing fluids. It's not a coincidence that the same king who ordered it also attempted one of the earliest flood control projects recorded in history. The Assyrians didn't just know how to move water, they knew how to tame it. But the mastery didn't stop in the Near East. Jump across centuries and oceans to the Maya civilization in Central America, and you find hydraulic miracles grown from jungle stone. Maya cities like Tikal and Palenque didn't have rivers running through them. Their engineers had to catch the sky itself. They built elaborate reservoirs, canals, and even filtration systems using layers of sand and porous stone to purify rainwater. Some reservoirs show residue of chemical balance control, trace amounts of compounds used to keep algae at bay. That's water treatment over 1,000 years before the modern chlorination process. When drought came, these systems kept tens of thousands alive. Archaeologists using LiDAR imaging have only recently realized how vast those networks were, entire cities, interconnected by invisible veins of water flowing beneath plazas and temples. What all these systems share is a deep environmental awareness. They weren't forcing nature to obey, they were collaborating with it. The Persian Qanats worked because they respected the slow gradient of the desert slope. The Assyrians succeeded because they matched the river's rhythm. The Maya thrived because they worked with rainfall, not against it. This is hydraulic technology rooted in observation, not domination. And that's a lesson we still haven't fully relearned. Now slide over to the Mediterranean to one of history's most underrated feats, the Greek Galermi Aqueduct near Syracuse. 5th century BCE, 40 kilometers carved directly through limestone, guided by hand tools and oil lamps. The tunnels met perfectly in alignment, even though teams dug from opposite ends through rock. That means they surveyed angles and curves with millimeter accuracy without compasses or maps. Some scholars say they used sound, tapping on rock, listening to faint echoes to keep direction consistent, effectively using the mountain itself as a guide. Today, parts of it still supply water, 2.5 millennia later. How did they pull it off? Nobody's completely sure. Some claim they used primitive sighting instruments resembling a level, others think they triangulated with star positions. What's undeniable is that they understood geometry not just as theory but as a physical craft. They could translate abstract ratios into stone corridors you can still walk through. If the word engineering meant applied understanding of nature, then they embodied it centuries before the term existed. These weren't isolated innovations. You can trace a continuous global pattern: Assyrian stone aqueducts, Persian Qanats, Greek tunnels, Mayan reservoirs, all born from different cultures, yet each displaying the same mastery of hydrodynamics long before it was codified into science. It's almost eerie how often humanity discovers the same truths separated by continents. Maybe necessity breeds invention, or maybe there were shared ideas diffused through forgotten trade routes. Either way, the synchronization is too precise to dismiss as coincidence. Pause for a moment and picture it. A desert city glittering under moonlight, sustained entirely by underground rivers engineered 3,000 years ago. Or a jungle metropolis catching rain in stone lungs, breathing water through filters that never clogged. Or a Greek craftsman deep inside rock, torchlight trembling on tunnel walls, knowing that somewhere ahead, another craftsman is digging toward him, and they'll meet perfectly. Water bending to human design, centuries before modern hydraulics defined the math. When Roman aqueducts later took the spotlight, they inherited much of this unseen legacy. The difference? The Romans archived instructions, the Persians embedded them in terrain, the Mayans encoded them in architecture. Most of their manuals are gone now, washed away by war and time, leaving us with structures that function but don't explain themselves. That's the haunting part. We can measure their results, we just can't fully reproduce their precision with the same simplicity. So maybe these weren't just engineers. Maybe they were philosophers of flow, thinkers who saw the link between water, life, and eternity. They built systems not for decades, but for generations, designing permanence in an impermanent world. And that's what makes them timeless. Because controlling water isn't just science, it's storytelling. Every drop still running through those ancient channels is a line of that story, still being read by the earth itself. And while those systems whispered in the language of gravity, some civilizations discovered something far stranger: how to make matter sing. They didn't just move water, they tuned the earth itself. Temples that spoke, the acoustic secrets of ancient ruins. Sound is invisible, yet somehow ancient builders managed to shape it, trap it, bend it, and turn it into an experience so immersive that even today we don't fully understand how. They built temples that could whisper back, chambers that echoed like voices from the underworld, and staircases that could sing to the sky. These places didn't just house rituals, they were the rituals. Take the highlands of Peru 3,000 years ago in a labyrinth of stone called Chavan de Huenter. Visitors approaching its temple didn't hear silence. They heard music, deep pulsing tones that seemed to rise from the stone itself. Archaeologists later found evidence of shell trumpets buried in the tunnels, and when they tested the structure's acoustics, something extraordinary happened. The sound waves ricocheted through the galleries, recombining to create eerie harmonics that mimic the human voice. One low note could make the walls hum. Two horns could make the air tremble like thunder rolling beneath your feet. Some chambers even filtered sound so precisely that priests' voices boomed from hidden corridors, as if the gods themselves were speaking through rock. For centuries, scholars dismissed these designs as coincidence, just clever architecture meeting physics. But modern acoustic mapping changed that view. Every passage's angle, every junction's curve seems intentional, tuned to channel resonance toward the main ceremonial hall. Under torchlight, with flickering shadows and those haunting frequencies reverberating off stone, the sensory effect would have been overwhelming. People didn't just hear their gods, they felt them vibrating through the walls. Now jump from Peru to England, where another monument once sang to the wind: Stonehenge. Most people see it as a giant calendar or sacred marker for solstices, but when researchers used acoustic modeling, they found that the ring design amplifies certain sound frequencies, specifically around 47 to 60 Hz, a deep bass range you don't just hear, you experience in your chest. In controlled experiments with replica stones, speech became unintelligible outside the circle but crystal clear inside, as if the air within the henge sealed off an invisible chamber. Some frequencies even created low vibrations too deep for the ear but strong enough to trigger physiological effects, a flutter in the chest, a shiver across the skin. Think about the implications. Thousands of years before concert halls or soundproof theaters, prehistoric builders created an open-air structure capable of manipulating resonance. They might not have spoken of frequency or amplitude, but they understood them intuitively. And maybe that's the point, they weren't trying to manufacture sound, they were orchestrating an experience. Across northern Europe, ancient barrows and burial mounds echo the same trick. Literally, researchers sent pulses of sound through these earthworks and found that many produce standing waves, tones sustained by the shape of the mound itself. Certain barrows even generate multiple harmonics, almost like natural organs keyed to the human voice range. In some, a whispered chant will loop back seconds later, warped and distant. It's easy to see how those echoes could be interpreted as voices of ancestors or spirits responding to prayer. There's a repeating pattern here, sacred structures that double as sound instruments. They may have taught through vibration what words couldn't express. Ritual participants would feel rhythm traveling through their bodies, synchronizing breath and heartbeat. It's not hard to imagine altered states achieved not by hallucination, but by controlled acoustics. Further evidence appears in Maya architecture, though on another frequency altogether. Visit the temple of Kukulkan at Chichen Itza and clap once at the base of the staircase. The echo that returns is uncanny sharp, melodic, like a bird's chirp. Specifically, it matches the call of the quetzal, a sacred species tied to the serpent god Quetzalcoatl. Engineers analyzing the echo confirmed it. The stair geometry acts like a resonator, sculpting a simple sound into a perfect imitation. Whether by careful design or long refinement, the effect would have been unmistakable, a symbol written in sound. To ancient attendees, it wasn't physics, it was communication. Even wind itself was harnessed. Certain temple shafts and cave openings throughout Central Asia and South America hum when a strong breeze passes through, like colossal flutes hidden in rock. Some of these frequencies fall just below human hearing, producing sensations of fear or awe, the same infrasound frequencies modern researchers associate with supernatural perception. That's right, structures built in prehistory accidentally or deliberately replicate phenomena that modern psychologists know can alter mood and perception. Skeptics call it natural happenstance, acoustic coincidence shaped by weathering and luck. But coincidence repeated across continents starts to look like knowledge. When you realize that cultures separated by oceans somehow shared the same intuitive grasp of resonance, you begin to see sound as one of humanity's first sciences. These builders didn't write equations, they conducted experiments with stone. And maybe that's what makes Archaeoacoustics so enchanting. It blurs the edges between science and spirituality. You can measure reverberation times, decay rates, and modal frequencies all you want, but none of that explains why people built entire temples around them. The answer might not lie in numbers at all, it might lie in intention. These cultures believed sound could bridge worlds, the living and the dead, the earth and the divine, the seen and the unseen. For them, sonic architecture wasn't art, it was technology for transformation. Picture standing in a dark gallery at Chavan de Huenter, the torchlight trembling. Someone blows a conch horn, the air bends, the walls answer. A low moan crawls up through the floor and into your ribs. Every breath sinks to the vibration until you can't tell if it's fear, faith, or physics taking over. That's not illusion, that's engineered emotion. Whether by design or by accident, the ancients learned to make silence sing. And that might be the most sophisticated trick of all, using architecture not just to shelter the body but to shape the mind. Because when stone begins to speak, it changes how you think. And if they could tune walls to move the human spirit, it makes you wonder, what else did they make stone do? Impossible monoliths, engineering feats that shouldn't exist. Picture this, a limestone block weighing more than 100 tons slides into place so precisely you can't fit a razor blade between its edges. No concrete, no steel framework, just gravity and accuracy. The Great Pyramid of Giza still holds that secret in plain sight. 4,000 years later, its alignment to true north is off by less than 3 arc minutes. That's more accurate than some modern city grids. The base spans 13 acres, yet each side deviates in length by only a few centimeters. How do you build something that perfect when your best tools are copper chisels? Archaeologists say it was patience, organization, human labor. True, but numbers tell another story. 2.5 million blocks moved and placed in about 20 years, some weighing as much as 40 tons each. That's one block set every couple of minutes for 2 decades with millimeter precision. It suggests logistics on an almost industrial scale, surveying technology capable of maintaining right angles over kilometers. Some researchers point to water-leveling trenches or sighting rods aligned with stars. But when you stand there at sunset and see the shadows swallow the desert in exact symmetry, it feels less like chance and more like knowledge we no longer have words for. And the precision doesn't stop at the surface. Inside, the king's chamber stones interlock like a three-dimensional jigsaw, distributing pressure evenly across the ceiling. Modern engineers studying its load paths admit the internal geometry minimizes stress the same way computer modeling does today. We rediscovered that principle 4,000 years later with finite element analysis. They just knew. Now travel north to Lebanon to the ruins of Baalbek. There, 3 colossal stones lie stacked in a foundation wall known as the Trilithon. Each weighs around 800 tons, and nearby, 1 block left in the quarry tips the scale at over 1,000 tons. For context, that's about the weight of 150 African elephants. The site dates back thousands of years before cranes or hydraulic presses existed, yet the stones not only were cut and transported, they were placed with precision measured in centimeters. You can see where lighter stones were fitted directly atop them, alignment flawless. Let that sink in. Moving an 800-ton boulder would challenge modern heavy-lift equipment, requiring modular transporters and precision cranes. No ancient wheel or rope system we know could handle the load. Some suggest sledges on lubricated tracks, others rolling logs on earthen ramps, but calculations break down under friction and terrain. There's a physical limit. We're missing something fundamental about how they handled mass on that scale. Maybe they understood counterweights or vibration-assisted transport far better than we realize. Maybe what we call brute force hit a kind of quiet physics. Then there's Puma Punku in the Bolivian Andes, altitude 12,000 feet, air-thin, stone harder than granite. The site looks like it exploded, blocks scattered like a giant's toys, yet each fragment carries cuts so sharp you can trace them with your fingertip and feel no imperfection. Stones interlock in complex patterns, puzzle piece joints with right angles and multiple recesses, carved to tolerances that match modern machine work. These aren't random fractures. They were modular components for buildings that could be disassembled and rebuilt like massive stone Lego. Microscopic analysis of the tool marks shows parallel striations as if cut by high-speed rotary equipment. But there's no evidence of metal tools hard enough to make those grooves. Archaeologists attribute it to patient abrasions. Sand and cord saws moved back and forth for weeks. Possible maybe, but the scale and uniformity suggest something more repeatable than trial and error. Experiments with hand tools rarely come close. Whatever process they used, it behaved like engineered precision manufacturing. And remember, this is before the wheel even reached that region. How do you carve igneous andesite with Bronze Age implements? You don't unless you've discovered a technique we've forgotten. Move again far into the Pacific to Easter Island. Everyone knows the statues, the moai towering solemn faces watching the horizon. The largest weighs over 80 tons. Archaeological consensus says islanders carved them from volcanic rock and moved them miles to their coastal stands. But the quarried path rises and dips over rugged terrain. How do you shift an 80-ton statue upright across uneven ground without breaking it? The locals say the statues walked. That sounds mythic until you test it. In 2012, a group of archaeologists recreated the feat using ropes and physics, rocking the statue side to side while guiding its forward motion with alternating pulls. It did walk slowly, majestically, balanced by gravity. The discovery proved something profound. Those builders combined intuition, rhythm, and precise weight distribution to animate stone. They didn't think like laborers, they thought like engineers choreographing movement. Every statue's center of gravity, every curve in its torso, seems designed for motion. So the myth wasn't exaggeration. It was observation preserved as story. Now trace the theme: pyramid precision, Baalbek mass, Puma Punku accuracy, Easter Island mobility. Different continents, different cultures, yet all show a mastery of physical principles: gravity, balance, stress, leverage that we usually credit to modern science. What links them isn't mystery for mystery's sake. It's intent. Every structure was arranged to endure not decades but millennia, surviving earthquakes, storms, and empires. That durability implies intimate understanding of material behavior, compressive strength, load transfer, even resonance. They built with permanence as part of the blueprint. And sometimes the precision gets almost eerie. At Giza, the Great Pyramid's descending passage aligns with the star Thuban as it appeared around 250 BCE, guiding northern orientation to astronomical exactness. At Puma Punku, magnetic surveys detected consistent polarity across stones, like they were oriented deliberately during carving. Coincidence? Maybe. But if you see pattern repetition across unrelated civilizations, it hints at a shared intuition about how the Earth itself operates, a geometric common language. Our modern arrogance often assumes technology follows a straight line, from simple to complex, from primitive to advanced. Yet here we stand with laser rangefinders, still marveling at joints we barely understand. Perhaps the ancients worked empirically, thousands of generations testing, refining, memorizing outcomes without needing theory. Knowledge embedded in practice, not paper. That kind of learning dies easily, one collapse, one forgotten line of apprenticeship, and it's gone. We rebuild thinking we've advanced, unaware that we've been here before. Maybe we don't give enough credit to the human senses themselves. Imagine a mason running a hand across granite, feeling microscopic texture changes, adjusting by instinct, or surveyors sighting stars over water channels to trace perfect lines. They were instruments as much as craftsmen. The precision tools might have been human. We lost that tactile intelligence when machines took over measuring. It's tempting to drift into speculation, aliens, lost continents, antediluvian empires, but the truth might be more awe-inspiring. Humans, using only what nature offered, achieved near-modern feats through discipline and cooperation. The impossible label reflects our ignorance, not their secrets. Still, unanswered questions linger. Why invest generations moving 1,000-ton blocks when smaller ones would suffice? Was it ritual prestige, or did size itself serve function, mass-dampening vibration, resisting time? At Baalbek, those foundation stones sit directly under Roman additions, proving each civilization trusted the base more than their own architecture. When the Romans found something already perfect, they built on it instead of rebuilding it. Maybe that's the thread running through every impossible monolith: endurance as message. They weren't just building monuments. They were encoding memory into matter, writing their names in gravity because ink fades. Their technology wasn't about convenience, it was about communication across epochs. So when we call their work impossible, maybe we're revealing more about our limits than theirs. They worked with time as their collaborator. We measure success in years, they built for eternity. Every block aligned to stars, every ton lifted by hands now dust, yet still in place, proof that intelligence doesn't depend on silicon or electricity. It depends on will. Look closely at those stones, and you start to realize something humbling. The most advanced structures on Earth were conceived when the rest of civilization was barely learning to write. Maybe they didn't need our machines because they figured out something different: how to synchronize effort at a scale we've lost the patience to attempt. And that's the riddle Baalbek, Giza, Puma Punku, and every silent monolith keeps asking us. Did we really invent precision or just rediscover it? Because if they could lift mountains, carve granite like butter, align monuments to the cosmos with a stick and a shadow, what else did they know about energy, balance, and the earth beneath their feet that we still haven't relearned? The deeper we look, the less certain the boundary between myth and math becomes. And from these impossible stones, the next mystery rises, not carved in rock but captured in force itself. Because sometimes power didn't come from lifting matter. It came from harnessing something unseen, something that might still hum quietly through the relics they left behind. The ancient power debate: myths or machines. The deeper you go into ancient engineering, the more one question starts to hum beneath every discovery. Where did the power come from? We're talking about energy, literal mechanical and chemical force. Because lifting stones, smelting metals, lighting temples, none of that happens without a source. And buried in legends across continents are whispers of devices that generated something more than muscle. Some called them relics, others called them sacred. Modern scientists, they're still not sure what to call them. Take the artifact found near Baghdad in the 193s. A simple clay jar, a copper cylinder, and an iron rod sealed with asphalt. To a museum curator, it's pottery. To an engineer, it looks suspiciously like a primitive galvanic cell, a battery. Pour an acidic liquid inside, something like vinegar or wine, and you get a measurable electric current. A weak charge, yes, but repeatable. If this were built deliberately, then we're not talking symbolic ritual. We're talking chemistry over 2,000 years before Volta. Experiments in the 20th century recreated it. Zinc replaced iron, copper cleaned and rewrapped. The result? Enough voltage to electroplate small objects with a thin layer of silver. Now that detail matters. Early Parthian and Sassanid jewelry sometimes shows a mystery sheen, silver bonded atop gold without visible solder. Was that aesthetic choice, coincidence, or experiment? Nobody can prove intent, but if those jars were indeed functional, it means the ancients weren't just observing static shocks. They were storing electricity. Still, skeptics warn against anachronism. Maybe the jars were for scroll storage or ritual oils. Battery was a modern projection, they argue, fair, yet the fact remains they can work as batteries. The question isn't whether they did, but whether someone discovered the effect accidentally, saw a spark, and walked away from what could have become an electrical age 2 millennia early. The thought alone bends history. And that's hardly the only electrical rumor lighting the past. In Alexandria, Greece's mechanical capital, legends tell of temples where statues moved and doors opened by themselves at sunrise. Sounds mythical, until you realize ancient engineers like Hero of Alexandria wrote treatises detailing exactly such mechanisms. He described systems using hidden siphons and heated air to create pneumatics, temples literally powered by temperature and pressure differentials. When morning sunlight heated a concealed cauldron, expanding steam displaced water, shifted counterweights, and swung doors open. Worshippers saw divinity, engineers see the earliest recorded use of thermodynamics. Hero's prototypes were toys for gods and kings, singing birds, automatic fountains, even what he called eolipals, hollow spheres that spun using escaping steam, a steam-powered device in the 1st century AD. In microcosm, the concept behind modern turbines already existed, ancient proof of concept for power through heat. So the puzzle isn't invention, it's adoption. Why didn't this ignite an industrial revolution of its own? Maybe because energy then meant wonder, not utility. Machines served ritual, not labor. Technology wasn't an industry, it was spectacle bound to belief. Then come the stories of Archimedes, the mathematician warrior of Syracuse, said to have burned Roman ships using fire mirrors. Centuries of retelling turned it legend, massive bronze shields focusing sunlight until sails ignited. Modern physicists tested the idea with modern mirrors. It works barely under ideal conditions. In the Mediterranean noon, concentrated arrays could scorch wood at close range. Whether Archimedes deployed them effectively, we may never know, but the physics stands. The myth had math behind it. What this hints at is pattern, experimentation with forces, electrical, optical, thermal, all before our so-called modern era began. Maybe they didn't name voltages or joules, but they observed cause and effect with relentless curiosity. They might not have isolated electricity as science, but they felt its shock in amber and lightning. They might not have mastered combustion engines, but they captured expanding gases in bronze flutes and valves. The line between experiment and ritual blurred completely. Now shift towards something quietly miraculous, Roman concrete. It's not glamorous, just gray rubble holding up aqueducts and harbors, but under a microscope it acts alive. When cracks form, water seeps in, reactivating chemical reactions between volcanic ash and lime. The material heals itself, sealing fissures within weeks. Scientists only identified this self-healing reaction recently, using scanning electron microscopy. The Romans achieved it almost absent-mindedly, claiming their mixture grew stronger with age. That wasn't poetic exaggeration, it was chemical fact. It means every Roman harbor that still stands owes its longevity to embedded energy, chemical design storing potential action until triggered by environment. That's the equation we normally credit to 20th century materials science. Yet the blueprint was hidden in recipes mixed by hand, measured by instinct. The ancients might not have built dynamos, but they infused matter with self-sustaining reactions. That's energy by another name. Then there's the Lighthouse of Alexandria, one of the 7 wonders. Contemporary descriptions speak of mirrors, glass, blinding beams visible far across the sea. Built on Pharos Island, the structure supposedly turned night into day. Scholars debate whether it used polished bronze mirrors to redirect sunlight or oil lamps amplified through reflective chambers. Either way, it manipulated light with intentional design. Some modern reconstructions show a rotating mirror system producing flashes, primitive optics, centuries before lenses became standardized. Imagine sailors steering by an engineered signal centuries before lighthouses became common across Europe. So maybe what connects these tales, the battery jars, the fire mirrors, the self-healing concrete, isn't mythology at all but a recurring spark of insight, glimpses of energy harnessed just long enough to astonish before vanishing into myth. Each experiment proved possibility, then faded without infrastructure to sustain it. Knowledge flickered, societies shifted, priorities changed. Innovations decayed faster than the stone that hid them. Of course, the question always arises, were these coincidences or fragments of a deeper science that slipped through our grasp? Hard evidence is thin, context matters, and rumor inflates easily. Many so-called ancient machines turn out to be ceremonial artifacts or natural curiosities, yet dismissing them outright feels naive too. Every myth begins somewhere, rooted in observation, remembered imperfectly. Maybe ancient engineers walked the edge of discovery, often enough to leave traces mistaken for magic. Skeptics call it pseudoscience to imagine lost electricity or secret reactors in famous ruins, and they're right to caution against fantasy. But when cold data confirms that Roman materials self-repair or that Greek optics understood focal length, it's no longer fantasy. It's respect for forgotten experimentation. The distinction we draw today between myth and technology didn't exist then. A miracle was just unexplained physics wrapped in ritual. That's the tension running through this debate. To ancients, energy wasn't extracted, it was invited. Fire wasn't industry, it was sacred breath. Magnetism wasn't field, it was spirit. They built around wonder, not apart from it. And maybe that's why we keep underestimating them. You can see it now, the analog battery humming faintly, the temple door sighing open with heat, the mirror flashing light across the bay, the concrete mending itself in silence. Machines or myths? Both. Proof that curiosity is the oldest energy source on Earth, one that never really ran out, just went quiet. But power didn't always come from fire, stone, or spark. Sometimes it came from the heavens themselves, from geometry written in sky and shadow, where energy wasn't generated but measured. Because long before telescopes, long before satellites, our ancestors turned their eyes upward and built devices that mapped the universe with awe-inspiring precision. And that's where we go next. When ancient engineers became astronomers and temples turned into time machines calibrated to the stars. Tracking the stars, celestial tech, and ancient astronomy. For as long as humans have looked up, the sky has been our oldest map. Every glimmering dot carried information, time, season, direction, destiny. But somewhere along the way, our ancestors did more than admire the heavens, they measured them. With no telescopes, no compasses, and no written trigonometry, ancient engineers built machines of stone that tracked celestial movement with accuracy that still shocks modern science. Start with the shattered bronze fragments pulled from a shipwreck off the Greek island of Antikythera. When divers first hauled it up in 1901, nobody knew what to call it. It looked like corroded scrap, gears fused into rock. But as scientists cleaned away centuries of encrustation, teeth and cogs began to appear, 37 of them, interlocked with ratios too deliberate to be chance. This thing wasn't random, it was deliberate mechanism. Thousands of letters inscribed on its panels spoke of planets, eclipses, and calendar cycles. Modern imaging finally revealed what was hiding inside. A gear-driven calculator from the 2nd century BCE, capable of predicting lunar phases and planetary alignments years in advance. The Antikythera mechanism. Think about that, an analog computer built when most people still measured time by sundial. Its surviving gears, carefully milled bronze, show tolerances comparable to clockwork from the 18th century. Someone 2,000 years ago understood compound gearing, differential motion, and astronomical cycles, then encased that knowledge in a box small enough to hold in your hands. What makes it wild isn't just its existence, but its disappearance. Nothing even close appears again in history for more than 1,000 years. It's like civilization pressed pause on mechanical astronomy, erased the blueprint, and only rediscovered it after the Renaissance. Whoever built it, whether a student of Archimedes or an unknown genius, precision-engineered time. The universe was literally gear-linked into motion. And Greece wasn't alone. On Crete, the Minoans had long aligned their palaces with celestial rhythms. The Palace of Knossos, Phaistos, and Mallia all framed sightlines toward rising stars marking agricultural seasons. In some halls, sunlight at equinox streams perfectly through narrow corridors, striking ceremonial altars like an ancient optical clock counting harvests. At Knossos, carvings of spirals and rosettes echo the motions of Venus, whose cycle the Minoans tracked within minutes of modern accuracy. To them, architecture wasn't just space, it was a calendar in stone. Look farther west, across oceans and centuries, to the high plateaus of the Yucatan. The Maya lifted astronomy into pure mathematics. Their observatories, like El Caracol at Chichén Itzá, contain sloping walls and window holes calibrated to record solstices, equinoxes, even the 584-day cycle of Venus. The dome rotates slightly off cardinal directions, matching the planet's tilt against Earth. Priests stood within those chambers, counting days by streaks of sunlight, transforming skywatching into predictive science. Their calendars, combining solar and ritual counts, measured time so accurately that modern corrections amount to a few seconds. And they weren't alone in this hemispheric stargazing. Across the desert of Nubia at Nabta Playa, an arrangement of stones older than Stonehenge forms a circular alignment with the summer solstice sunrise. This prehistoric observatory predates agriculture in much of the world, yet its builders oriented monoliths to cardinal directions with eerie perfection. Who stood there first, watching dawn break exactly between those slabs, marking the turn of the year? Whoever they were, they encoded astronomy into Earth itself before writing existed. From Mesopotamia's ziggurats to Britain's standing stones, night sky geometry shaped civilization. Temples, pyramids, and towers all doubled as cosmic instruments. Egyptian priests tracked the rising of Sirius to forecast the Nile flood, turning celestial observation into social survival. Even ancient Indian texts describe the measurement of lunar mansions, nakshatras, systematic divisions of the sky used for navigation and agriculture. Around the globe, civilizations separated by oceans converged on the same realization. The heavens operated like a machine, predictable and measurable, if you paid close enough attention. But what's astonishing is the precision. At Chichén Itzá again, during equinox, sunlight falls along the steps of the temple of Kukulkan in a serpent-shaped pattern that slithers downward as the day progresses. Architects oriented every angle to capture that exact illusion, proof of understanding solar inclination down to fractions of a degree. In Egypt, the Great Pyramid's shafts point toward Orion's belt and the circumpolar stars as they appeared 4,000 years ago, suggesting deliberate stellar calibration. In Greece, the Parthenon's proportions reflect harmonic ratios matching lunar cycles. Across continents, math met myth, and together they became a form of technology, the control of time itself. So how did they do it? No telescopes, no chronometers. Yet through centuries of observation, priests and astronomers recorded rising points, declinations, eclipse sequences. They stacked data in oral memory, transcribed it into alignment. Imagine generations standing beneath identical skies, adding one small correction each season until architecture itself became a record of perfect synchronization. For them, building meant calibrating humanity to the cosmos. There's another layer here, the translation of sky to land. Many ancient city grids mirror constellations. Teotihuacan's Avenue of the Dead aligns roughly 15 degrees east of north, matching the setting of the Pleiades cluster precisely when rituals signaled the start of their new century. In China, imperial capitals traced layouts resembling celestial diagrams, positioning palaces as earthly analogues of heavenly palaces. It's as if every civilization ran the same experiment: replicate the order overhead to stabilize the chaos below. When you step back, patterns emerge, geometry repeating like a forgotten algorithm. Nabta Playa in Africa, the pyramids of Giza, the Orion correlation, Angkor Wat's towers mapping Draco and Virgo, the Mayan calendar syncing to the long count of precession. Each independent, yet all describing the same astronomical constants: solstices, equinoxes, Venus, Orion. Coincidence stretches thin. Maybe the sky united us more deeply than we realize. It was the first shared database, accessible to everyone, immutable and eternal. We often think precision astronomy began with telescopes in Renaissance Europe, but the groundwork was carved millennia earlier. Babylonian astronomers could forecast eclipses using the 223-month Saros cycle. Greek mathematicians computed Earth's circumference within a percent of modern value. Polynesian navigators memorized star lattices connecting entire oceans. Together, they formed an intergenerational network of observation, the first global scientific collaboration conducted silently across centuries. Even more intriguing is how those observations crossed boundaries. Egyptian and Mesopotamian star lists share numerical systems. Minoan and later Greek calendars echo Babylonian lunar counts. And thousands of years later, Maya and Inca astronomers, isolated by oceans, tracked planetary movements with nearly identical intervals. Either every society stumbled upon the same cosmic constants through sheer persistence, or fragments of knowledge diffused along forgotten routes. Trade, migration, myth, it doesn't matter how. The result is the same: convergent genius. Imagine one of those nights. A Maya priest stands beneath a humid sky, chalking another glyph into limestone, the moment Venus returns after its 584 days. On the other side of the world, a Babylonian scribe engraves a cuneiform tablet marking the same event. They'll never meet, never know each other existed, yet both are synchronized across time and planet. That's not superstition, that's global science before globalization. What these structures show us is a transformation of perception. Ancient astronomers weren't staring upward for curiosity, they were building feedback loops between heaven and earth. Every observation shaped architecture, every building refined measurement. The Antikythera mechanism is the mechanical endpoint of that process, a portable cosmos. But it's also a reminder that technology isn't linear. Once, our ancestors could predict eclipses without physics degrees, align monuments without lasers, and compute planetary motion using bronze gears and patience. We call their tools primitive because ours glow and theirs don't. But the function, the drive to codify the universe, hasn't changed. Maybe that's why monuments like Nabta Playa or El Caracol still feel alive. They're time machines locked in perpetual dialogue with the sky. When the solstice sun hits those stones exactly as it did thousands of years ago, you realize they never stopped working. Across all these sites, one idea rises above the details. For ancient engineers, the cosmos wasn't distant, it was interactive. The sky was a guide, a clock, a teacher. They studied it, domesticated it, and built machines to speak its language. And when those machines stopped turning, humanity forgot the conversation. But look at the legacy left behind: the gears, the alignments, the sun snakes, and star shafts. They whisper a message as old as civilization. Understanding the heavens was humanity's first high technology. And maybe before we built rockets or observatories, we already achieved a kind of space travel, an intellectual one, crossing infinite distances through observation alone. They watched the sky, yes, but what's more remarkable is how they mapped the earth beneath it. Because to know the heavens, you need a fixed point below. And somehow, long before satellites ever drew a global outline, our ancestors created maps that shouldn't exist. That's the next question: how did they chart the world with such impossible accuracy? Ancient maps and global knowledge. Maps are supposed to tell us where we are, but some ancient ones tell us something even stranger, where we shouldn't have known to be. The moment you look at them too closely, history itself starts to twist. Case in point, the Piri Rise map drawn in 1513 by an Ottoman admiral whose sources predated Columbus. It shouldn't be remarkable, except it depicts the coast of South America in perfect proportion, and below it, a landmass shaped suspiciously like Antarctica. Remember, Antarctica wasn't discovered until 300 years later, and this version, it's drawn without ice. Modern geological surveys of the subglacial coastline match its outline eerily well. Either it's an impossible coincidence or somebody had cartographic data that shouldn't have existed. The admiral himself wrote in the margins that he based his map on ancient charts from the time of Alexander and earlier. No one knows what those were or where they came from, yet the precision along South America's eastern edge mirrors satellite projections. Some researchers argue misinterpretation, maybe he accidentally duplicated a distorted Africa, but the mathematical consistency runs too clean. It's the kind of geometry that suggests global measurement, like whoever first charted it understood Earth as a sphere, not a flat plane. Which raises a bigger question: could prehistoric seafaring cultures have gathered partial global maps long before exploration even existed? Because long before Piri Rise inked his parchment, Eratosthenes in ancient Greece had already calculated the Earth's circumference using nothing but shadows. Around 240 BCE, he noticed that at noon on the solstice, sunlight reached the bottom of a well in Sine but cast a shadow on a staff in Alexandria. Using the distance between the two cities and the angle of the shadow, he measured the planet at roughly 40,000 kilometers, off by less than 1% of modern satellite figures. No telescopes, no GPS, just logic and a stick. That single experiment shattered any notion of a flat Earth in the intellectual centers of his era. Ironically, 2,000 years later, we still argue about what he proved in an afternoon with sunlight. Eratosthenes also built an early prototype of latitude lines, imaginary divisions of the Earth based on the sun's angle, not political boundaries. His library in Alexandria stored hundreds of scrolls compiling trade routes, wind directions, and star charts used by navigators from across the Mediterranean, Africa, and Asia. To him, geography wasn't guesswork, it was data science. And when the library burned, much of that proto-atlas burned with it. You can almost feel history dim a little every time paper turns to ash. Yet measuring Earth wasn't only a Greek obsession. Ancient Indian scholars in the Gupta period described a circular world surrounded by sea, estimating its diameter in yojanas, numbers that, when converted, again hover near accurate values. Chinese astronomers mapped latitude by Polaris height centuries before magnetic compasses evolved. And Roman surveyors built entire empires on precision grids. Their roads, aqueducts, and property lines still trace an implied coordinate system visible from orbit. The myth that only modernity saw Earth as round collapses under its own weight. The ancients knew the globe long before they could see it. But that knowledge didn't stop at concepts. Pieces of global mapping keep surfacing where they shouldn't. Fragments of medieval portolan charts in the Mediterranean show Atlantic islands unknown to recorded sailors. South American petroglyphs bear nearly accurate coast outlines. Even in Polynesia, stick charts made from palm ribs encode ocean swells, currents, and island chains across thousands of miles, 3D representations of forces, not distances. Each one is a different way of thinking about geography, not a picture of land, but a feeling of movement and relationship. Combine enough of them, and maybe you get the first true world map, assembled invisibly through shared voyaging memory. That possibility edges into something larger, the idea of cross-continental contact before Columbus. Archaeological finds keep suggesting it: South American cocaine and nicotine molecules detected in Egyptian mummies, Roman coins washing up in Okinawa, Old World plants appearing in pre-Columbian gardens. Most evidence remains circumstantial, yes, but the pattern grows steady. Trade currents may have carried more than goods, they carried information. Even a single successful transoceanic journey could scatter cartographic seeds that later mapmakers stitched together centuries later. It's tempting to picture a forgotten consortium of sailors, maybe Phoenician or Arab, traversing the equator and returning with tales drawn into geometric form. The knowledge passes through temples, monasteries, libraries, collecting like sediment until someone like Piri Rise inherits fragments without context. We see the end product, not the network behind it. The same way our digital maps now rely on countless unseen satellites, their charts may have relied on innumerable unnamed observers. Meanwhile, back in Rome, geographers such as Strabo and Ptolemy tried to impose order on the swirl of reports, designing giant coordinate grids to contain the known world. They even proposed methods for projecting a sphere onto a flat surface, precursors to the Mercator projections still used in classrooms. What they lacked was data from the entire planet. But give those systems the extra coastlines from a Piri Rise source, and you start to approach near modern mapping centuries ahead of its time. It suggests that ancient cartography wasn't purely continental. It already imagined a world system, even if its borders faded into myth. And behind every map lies motive. The Greeks measured for philosophy, the Romans mapped for power, the Chinese charted for administration, Polynesians memorized for survival, yet all share one revelation: mapping is the act of turning experience into permanence. It converts movement into knowledge. That's technology in its purest form. Today we draw maps instantly, satellites scanning every meter of Earth in seconds, but accuracy hasn't solved mystery, it's just digitized it. Because those ancient charts still whisper from library shelves, their coastlines sharper than they have any right to be. Who first traced them? How did they measure thousands of miles of sea they'd never sailed? And what did they know about this planet that we forgot? Maybe the answer sits in the same place the first explorers looked: the relationship between heaven and earth. To map the world accurately, you first needed to fix yourself among the stars. The ancients did that instinctively. Their maps weren't just drawings of land, they were dialogues between sky and sea. Which makes sense: navigation led to mapping, and mapping led to connection. So as the Piri-Rise parchment fades behind museum glass, think about the continuum it represents. From shadow calculations in Greek wells to Polynesian wave algebra, from Roman survey stakes to Maya observatories. Every line, every coordinate, every ripple in that lineage says the same thing: humans have always been global thinkers trapped in local ages. The planet didn't get smaller because we invented GPS. It got smaller because we finally remembered how big our ancestors already knew it was. And even without our satellites, they managed to see the outline of a world we're still trying to understand. Which leads to the next puzzle: how the people who charted continents also mastered matter itself, forging materials that refuse to die even now. They drew the earth, then learned how to outlast it. That's where we're going next. The forgotten chemistry code written in stone and steel that time still can't erase. The code we lost: materials and chemistry beyond our time. Some technologies don't hum or shine, they endure. They sit silent in the ground, defying decay, reminding us that chemistry once carried a strange kind of poetry. The ancients mixed fire, earth, and intuition, producing materials that modern labs are still trying to understand. If the earlier wonders were monuments to geometry and motion, this was their code, the molecular intelligence of civilizations. Start with a metal that shouldn't exist in its own time: Damascus steel. Legends say it could slice a silk scarf drifting on air, yet never dull. Blades forged in Syria and India between the 3rd and 17th centuries shone with rippling patterns like smoke frozen in iron. Tests on surviving swords reveal something unnerving: carbon nanotube-like structures within the steel's matrix. Microscopic formations modern metallurgists only began manufacturing intentionally in the late 20th century. Scientists recreated the process once, then lost it again, realizing the secret relied on impurity content in ore now geologically gone, and controlled cooling rituals described only as superstition. These smiths turned chemistry into art and intuition into nanotechnology without ever naming it. Follow that pattern of accidental genius and it leads straight to Roman cement, the concrete that rebuilds itself. At first glance, it's drab rubble binding aqueduct arches, harbor blocks, and temple domes. But slice it thin under a microscope and you see bright crystals of calcium aluminum silicate hydrates. When seawater seeps through cracks, those crystals reactivate, forming new minerals that reseal the structure. It's chemical immortality, autonomous repair triggered by nature. Modern engineers grind, heat, and pour synthetic versions to mimic it, but the Romans mastered the formula using volcanic ash called pozzolana mixed with lime and seawater. They thought it permanent because it resisted Neptune's rage, but they didn't realize they'd invented the first self-healing material. Fast forward to China's Han Dynasty, where alchemy disguised itself as ceramics. Craftsmen, their perfected glazes so advanced that modern electron microscopes reveal layered nanostructures controlling how light reflects. Those shimmering celadons and deep blues weren't accidents, they're optical interference films engineered by human hands centuries before spectroscopy. Firing temperatures and oxygen levels were adjusted by color memory. Potters judged hue by flame tone, not thermometer. Some glazes fused metallic ions into the clay matrix, forming conductivity levels measured today in semiconductors. They made beauty that functioned like technology. Meanwhile, in Egypt, chemistry turned into light itself. Egyptian blue, the first synthetic pigment, appears in murals older than the pyramids. For thousands of years, nobody questioned it. It was simply divine hue reserved for gods and skies. Only recently did scientists uncover its hidden trait. Under infrared, it fluoresces brilliantly, emitting energy in stable near IR wavelengths. That means it converts sunlight into invisible radiance, a property researchers now exploit for solar panels and medical imaging. A coloring accident from 250 BCE carries potential applications in 21st century photonics. Ancient chemistry, future energy. And it wasn't just pigment or metal. In Persia, glassmakers discovered composite resins that bonded pigments inside translucent silica, a primitive form of fiber coating protecting color from fading. On the other side of the world, Mesoamerican artisans produced Maya blue, a pigment so chemically stable it survives in humid jungles untouched by mold. The secret? They blended indigo dye with palygorskite clay, forcing organic and mineral molecules to interlock. It's basically an ancient polymer, resistant to acid, sunlight, and time. Modern pigments crumble within decades. Maya murals still blaze with saturated blues after a millennium of heat and rain. Nobody else has replicated that durability. The theme repeats, matter fine-tuned by observation rather than equation. These craftspeople couldn't define crystalline lattice theory, yet they manipulated atomic behavior through rhythm, heat cycles, charcoal timing, moon phases. Every workshop was a laboratory run on mythic schedule. In Damascus, smiths whispered prayers at specific cooling stages, unknowingly controlling carbon diffusion. In Egypt, pigment makers chanted about rebirth while oxidizing copper silicates to produce luminescence. Ritual became process control. But let's widen the frame. Why did these materials matter so much? Because they lasted and endurance was a sacred concept. For Romans, longevity equaled divinity. Concrete that hardens underwater mirrored immortality. For Chinese alchemists, glaze that captured light embodied transformation. For Egyptians, color that glowed in darkness symbolized eternal life. Chemistry was theology done with fire. They didn't separate science from spirit. Stability itself was evidence of communication with the gods. Now picture how many of these materials we've rediscovered accidentally. In 2006, a German team analyzing Roman seawalls found small limeclasts inside that, upon contact with water, created new minerals identical to those forming cements today designed for Mars habitats. In other words, ancient harbor ruins became prototypes for interplanetary construction. Engineers now study them to build self-healing concrete for lunar bases. Past becomes blueprint for future. Even textile chemistry carries echoes. Indian dyers mastered mordants that fix color at molecular level. Linen from Egyptian tombs still holds golden sheen where mordant bonds survived. Some samples test positive for unknown plant-based tannins forming graphene-like structures. Each discovery feels like finding a fingerprint too small for its time. So why did we lose these codes? A pattern emerges, knowledge tied to place dies with that place. Ores depleted, specific clays exhausted, workshops destroyed in wars. Guild secrets vanished with their masters. Industrialization later simplified recipes for scale, discarding unnecessary impurities, those very impurities that gave ancient materials their supernatural traits. We streamlined durability out of existence. There's an irony that modern science now digs through ruins looking for patents the ancients never filed. Microscopic studies of Egyptian blue inspire infrared sensors. Damascus steel guides nanocomposite research. Roman concrete informs climate-resilient architecture. We're mining memory instead of ore. But the mystery isn't just chemical, it's philosophical. How did people working by torchlight sense relationships between heat, color, and time so precisely? Because they paid attention. Observation lasted generations. Sons inherited not only formulas but intuition, how the smell of smoke changes when lime matures, how molten metal sounds when it reaches welding point. That's sensory data no textbook captures. When those sensory languages died, the art became legend. Imagine standing in a bronze workshop in ancient Syria. Sparks bloom, the air tastes of ozone and carbon. The master listens, literally listens to the pitch of hammer strikes to gauge hardness. He drips oil on cooling steel, the hiss tells him its future flexibility. He doesn't know he's controlling crystal dislocations, he just knows the blade will not break. That intimacy between maker and material is the code we lost. Even their failures were instructive. Roman builders added too much ash once and discovered lightweight pumice concrete, the ancestor of modern aerated blocks. Chinese smelters chasing immortality brews invented porcelain by accident, vitrifying clay until it sang when struck. Alchemist missteps gave us pigments, alloys, glass compositions still unmatched. Innovation hid in errors treated as omens. They observed anomalies, then worshipped them until repetition turned superstition into reproducible method. And here we are centuries later, firing lasers into samples to rediscover reactions our ancestors coaxed with torches. It's humbling. Technology didn't advance linearly, it pulsed. Bursts of brilliance followed by forgetting. The ancients coded their knowledge into matter, we decode it with microscopes, calling it progress. But maybe progress is just recovery. Look at a Damascus sword under museum glass, the wavy lines catching light. Within those ripples lies carbon arranged nearly at modern nanostructure precision, formed by men watching color, not measuring temperature. Hold a shard of Egyptian blue, it still glows like trapped sunshine after 4,000 years. Touch a Roman pier at Ostia, it feels alive, breathing seawater into strength. Every relic is a message, you once knew how to make eternity. They built substances that outlasted empires, compositions that resist entropy, structures that heal, shine, or sing to invisible spectra. And yet, most formulas died with language itself. That isn't loss, it's latency. The code sleeps in the materials, waiting for minds curious enough to read it again. Because maybe technology was never only about machines or motion. Maybe it was always about relationship between human perception and physical law. The ancients mastered that relationship until their buildings became laboratories, their pigments became physics, and their metals became mathematics the body could feel. We look at their ruins and see archaeology, but what they left us is documentation written in durability. The only difference between their science and ours is notation. We use symbols, they used permanence. And that's the truth buried inside every ruin. Intelligence doesn't vanish, it weathers. It stains stone, it crystallizes in color, it hums faintly in rust that never quite spreads. The ancients left behind materials that still work because somewhere in their intuition lived an understanding we keep chasing, a chemistry of immortality. They didn't fear time, they engineered conversation with it. And that might be the greatest code we ever lost, the ability to build something and trust it to keep speaking long after we're gone. Ancient tech and the limits of modern understanding. Every time we uncover something advanced from antiquity, be it a machine, a pigment, or a mathematical alignment, there's one response that keeps echoing through the modern world: disbelief. We call it coincidence, anomaly, or misplaced ingenuity. Because admitting otherwise, that humans long before us matched or exceeded our capabilities, threatens the story we like most about ourselves, that progress only moves forward. But what if the truth is more cyclical? What if knowledge doesn't vanish, it just hides, waiting for rediscovery? The deeper researchers dig, the more that idea gains weight. Technologies vanish not because they stop working, but because the networks that sustain them collapse. Civilizations rise, specialize, fragment, and fall. Each one leaves a scattering of masterworks with no manuals attached. Take Damascus steel, the process depended on ore impurities from a single Indian mine. Once those veins ran dry, the legendary blades faded from history. Or the Minoan star palaces on Crete, brilliant alignments without written records. When that civilization sank into chaos, so did the astronomical tradition. Knowledge is only as durable as the people preserving it. Collapse kills libraries faster than fire. When the Library of Alexandria fell, tens of thousands of scrolls vanished, maps, experiments, formulas. For generations, oral tradition tried to keep fragments alive, but memory decays with every retelling. Without institutional backup, even the sharpest insights dissolve into myth. By the time someone rediscovers them, we treat them as miracles rather than reminders. It's not that ancient scientists lacked intelligence, it's that their worlds lacked resilience. Modern bias makes this worse. For centuries, Western archaeology framed history as a ladder, each rung a step toward enlightenment, with Europe at the top. Anything that didn't fit that climb was labeled outlier or ceremonial. Sophisticated toolmark on granite, ritual carving. Gear system too advanced for its date, probably decoration. Yet if identical precision appeared in a colonial factory record, no one would call it worship. The prejudice lies in assuming linear evolution, when the evidence screams recurrence. Experimental archaeologists are starting to close that gap. Rebuilding ancient machines, they find lost logic reawakened. You can 3D print a replica of the Antikythera mechanism and watch its gears spin flawlessly using ratios identical to planetary motion. Sailors recreating Polynesian wayfinding reach their destinations using sky alone. Chemists mixing Roman lime recipes produce self-healing concrete that modern engineers now patent. Each test proves what we should have known: intelligence doesn't belong to an age. It belongs to curiosity. So why does the disbelief persist? Because our identity depends on novelty. We measure worth by invention rates, patents, progress graphs. If an earlier humanity equaled us, the illusion of superiority cracks. Acknowledging their genius doesn't just rewrite textbooks, it questions the premise that technology evolves upward forever. Maybe progress is tidal, knowledge advancing in surges, retreating with catastrophe, returning altered but familiar. Every golden age leaves a low tide of forgetting. Think about the dark centuries that followed Rome. Plumbing vanished within decades. Literacy plummeted. Entire engineering principles were reinvented laboriously centuries later. The aqueducts still stood, but no one remembered how to calculate their angles. That pattern repeats again and again: collapse, amnesia, rediscovery. To future archaeologists, our own digital culture might seem mythic too. Imagine unearthing a smartphone with no satellites left in orbit. Its black glass would look like sacred stone. Context defines genius. Another subtle killer of knowledge is secrecy. Many ancient crafts existed as guarded guild traditions, oral codes passed from master to apprentice. That exclusivity maintained power but guaranteed extinction once the line broke. Alchemist recipes died with their authors. Astronomical data stored in temple priesthoods vanished when invasions leveled shrines. The paradox of mastery is fragility. The more specialized the knowledge, the easier it is to lose. Bias also blinds retrieval. When early archaeologists excavated hydraulic tunnels in Persia, they called them primitive wells. Only decades later did hydrologists recognize them as Qanats, precision water networks whose gradient control surpasses our own irrigation norms. The same mislabeling lingers elsewhere. Sonic temples, accidental acoustics, advanced navigation, primitive trial and error. We underestimate ancestors because our instruments look shinier, ignoring that their instruments were them. Yet there's hope in how rediscovery happens. Today's scientists use computational modeling and materials analysis to reverse engineer the intuition of the ancients. They simulate stress points in pyramid stone, track erosion angles to validate orientation methods, even decode pigment composition atom by atom. Each success erases a bit of arrogance and replaces it with awe. When spectroscopy confirms that Egyptian blue radiates infrared, we stop laughing at myths of luminous paint. When satellite photography reveals canal networks beneath Mayan ruins, we understand that the jungle swallowed not superstition but science. Maybe the reason ancient technology feels impossible is that we keep defining technology too narrowly. To us, it's circuitry and code. To them, it was cognition, pattern recognition elevated to survival strategy. A Polynesian navigator reading waves, an Incan stonecutter finding interlocking joints by sound, a Chinese metallurgist sensing temperature through hue, they're all using data processing, just in embodied form. Their laboratories were oceans, quarries, and kilns. Their memory banks were human brains trained to observe subtle pattern drift across decades. Imagine losing that calibration because literacy replaced apprenticeship. Books preserve formulas but erase feel. So the real mystery isn't whether lost civilizations possessed impossible machines. It's how they thought so holistically that tools were extensions of perception, not replacements for it. Modern science isolates, ancient knowledge integrated, astronomy informed agriculture, geometry shaped spirituality, chemistry served art. The boundaries we draw between disciplines didn't exist then. That's why their breakthroughs seem magical. They emerged from an ecosystem of insight we've disassembled for convenience. Today, as archaeologists and engineers collaborate, we glimpse how much lingers unnoticed. Advanced sonar imaging reveals perfectly straight canals under Saharan sands. DNA analysis redates Pacific migrations, aligning with oral star maps that skeptics once dismissed. Artificial intelligence compares architectural ratios across continents and finds recurring mathematical constants, proof that humanity's design vocabulary transcended isolation. Far from random coincidence, it looks like collective intuition preserved in stone. Still, many secrets may remain locked forever. Organic materials rot, paper burns, languages die. A lost formula scribbled on bark 2 millennia ago could have solved energy storage differently, disappeared without witness. Our modern datasets are just as vulnerable, fragile silicon dependent on continuous electricity. One prolonged blackout, one collapse, and our archives turn to silence. Then one day, some future archaeologist digs up an inert server rack and wonders how we powered an entire world with invisible lightning. History would loop again. Maybe that's the pattern carved through every era. Discovery, hubris, collapse, rediscovery. Intelligence never dies, it migrates, encoded in myth, ritual, proportion, or sound, waiting to be noticed by descendants who mistake it for revelation. The ancients weren't primitive dreamers peering into darkness. They were us at another frequency of understanding, fluent in materials and forces we're only beginning to translate back. Because when you strip away power grids and microchips, what remains is the same fire to understand, to build, to remember. They carried that flame through ages of drought and flood until memory failed. We hold it again now, brighter but just as fragile. Their ruins aren't reminders of inferiority. They're mirrors showing how easily brilliance fades when humility does not accompany it. Maybe progress isn't about surpassing the past but recovering conversation with it. Every rebuilt artifact, every replicated experiment is a handshake across millennia saying, "We remember." And in that recognition lies our truest advancement, the awareness that technology is temporary, but curiosity is immortal. Because maybe the greatest ancient technology wasn't forged in metal or carved from stone. Maybe it was inside us all along, a mind capable of mapping the cosmos, syncing with nature, and then erasing its own memory just to rediscover it centuries later. What we forgot, the mind as the first machine. For all the metal, stone, and pigment we've studied, maybe the most advanced technology the ancients ever built didn't exist outside their skulls. Because behind every impossible artifact lies a more mysterious engine, the human mind. That's the piece we keep underestimating. The idea that knowledge was a function of thinking, not tools. Before machines processed data, brains did, and they did it through rhythm, pattern, memory, and imagination. The first computer wasn't bronze or silicon. It was the collective human brain running the code of survival. Look at it this way, a Polynesian navigator could hold thousands of nautical variables in memory: wave direction, star position, bird flight, cloud color. Each element linked through association, updated constantly while crossing open water. That's computation. Information storage and real-time processing performed without a single written note. Their cortex was an algorithm calibrated by the ocean. The same goes for Minoan priests who tracked Venus's cycle across generations, or Maya astronomers who counted eclipses to the day. The hardware was organic, the output architectural. Today we depend on external processors to model complexity, but for most of human history, intelligence ran internally. Ancient builders visualized geometry instinctively. They carved perfect ratios not by calculation but by embodied familiarity, a sense of harmony between eye, hand, and material. Modern engineers would call that subconscious optimization. They called it craft. Their minds simulated stress loads by muscle memory, not software. What if technology once meant something broader, an alignment between thought and world? The ancients saw no boundary between science and intuition. Pattern recognition wasn't something they performed, it was who they were. Farmers tracked lunar cues because crops answered to time. Healers mixed herbs by rhythm because the body echoed nature's pulse. Every task trained pattern sensitivity until observation itself became tool. When that sensory discipline faded, replaced by abstraction and specialization, we gained mathematics but lost fluency in the planet's subtle code. Think about oral tradition. Without writing, memory had to be perfect. Knowledge survived by living inside people, songs encoding instructions, myths preserving measurement systems. Aboriginal songlines map entire continents through melody. Each verse marks a landmark, each rhythm a coordinate. That's GPS rendered through music. Language, rhythm, and geography fused into one cognitive architecture, neural pathways mirroring physical roots. The mind turned environment into data, body into instrument. In those systems, learning wasn't accumulation, it was transformation. A novice didn't memorize facts, they became part of a larger intelligence. Knowledge was embodied empathy with place. When Polynesian navigators felt currents through their fingertips trailing in water, that sensation was input data. When Egyptian architects mirrored stellar geometry, that was feedback calibration. They built feedback loops centuries before cybernetics assigned the term. Each culture reached cybernetic awareness through rituals, not laboratories. Some neuroscientists now argue that such practices expanded working memory and spatial reasoning beyond modern averages. Meditation, chant, repetitive motion, all neurotechnologies in disguise training attention and synchronization. Ancient monks who spent years reciting mantras weren't just seeking enlightenment, they were modifying neural wiring for focus. Modern brain scan studies on descendants of those traditions show enhanced pattern detection and emotional regulation. It's measurable. Their spiritual practices were literally mental programming. Maybe this is why stories of divine inspiration saturate ancient invention. To them, insight arrived as visitation, a god whispering formulas because they couldn't yet describe emergent intuition. When collective focus reached threshold, ideas appeared spontaneously, shared intelligence pretending to be deity. We call it genius now. They called it communion. Same phenomenon, different vocabulary. That raises an unsettling idea. What if civilization's great leaps weren't products of external technology but internal synchronization? When enough minds learn to think alike, observe, remember, connect, the combined network produced innovation. The Stonehenge builders didn't need a written code because their community consciousness was the code. Each worker embodied a fragment, together they formed processor and output, society as motherboard. Fast forward to us, we externalize that network into machinery. Data lives in servers, memory outsourced to algorithms. Efficient, yes, but also alienated. We delegate pattern recognition to computers that don't feel context. The ancients integrated environment, emotion, and logic in one loop. Their machines sang because they were extensions of empathy. Our machines hum because we've separated sense from meaning. When you watch footage of modern experiments recreating old skills, stonecutters aligning blocks by ear, sailors steering by starlight, you glimpse how intelligence feels when it's unmediated. The participants describe it as flow, trance, connection. That's cognitive synchronization with the external world. Call it spiritual, call it neurobiological, it's the same phenomenon. We knew once how to merge analysis and awareness, then replaced it with measurement and lost half the equation. So maybe the lost technology everyone hunts, the batteries, the gears, the alloys, isn't the real mystery. The real loss is the human operating system capable of generating them spontaneously. A mental firmware that stored centuries of observation not as data but as instinct. When societies fractured, that firmware corrupted. Apprentices died before training successors, rituals turned symbolic, intuition dulled through disuse. The hardware remained our brains, but the code rarely runs as it did. Every ancient wonder on this planet stands as an external snapshot of internal clarity. The pyramids, the Antikythera gears, the Qanats, the pigments, their materialized thoughts, evidence of minds disciplined enough to translate complexity into simplicity. The fact that we can't fully replicate them says less about missing tools and more about missing mental calibration. We've got more information than ever, but less synthesis. They had fewer signs, yet saw deeper patterns. Reframing technology this way changes everything. It means intelligence itself is renewable. Lost knowledge isn't gone, it waits dormant in cognitive potential. The same neural architecture that once mapped oceans and stars still sits behind our eyes, we just direct it elsewhere. Maybe true advancement isn't inventing new machines, but relearning how to think in harmony with what already exists. To notice the algorithms embedded in wind, sound, tide, color, emotion. Imagine rebuilding society not through devices but attention. Schools that teach sensory mathematics, architects who tune resonance, coders who study myth as system theory. It sounds futuristic, but it's older than writing. Because once humanity treated perception as sacred hardware. Every skill, singing, carving, navigating was firmware update, each myth an encryption of cognitive process. The ancients might look at our blinking screens and high rises and recognize only one familiar thing: curiosity. That's the constant thread, the unbroken line from stone tool to particle accelerator. Curiosity is the mind's engine, endlessly self-upgrading, occasionally self-erasing. When we forget connection, we fragment. When we remember, we innovate. Progress and amnesia, alternating beats of the same heart. So when we call this series Ancient Tech That Should Not Exist, maybe what we really mean is ancient minds that should not have disappeared. Because their greatest invention wasn't metallurgy or solar alignment, it was themselves, fully tuned instruments of attention. They proved consciousness can be engineered. And that realization flips the story. The past isn't a linear ladder of tools climbing toward us, it's a circular mirror reflecting how potential recycles through awareness. Our ancestors built external monuments to internal mastery. We build internal confusion around external convenience. Somewhere between those extremes lies balance, the memory of harmony between thought and world. Perhaps that's the final paradox history leaves us. The future of technology might depend on resurrecting an ancient state of mind. Not mysticism, not nostalgia, just remembrance. Because maybe the original machine never stopped running. It's still here, warm behind our foreheads, waiting for us to log back in. The echo of genius. Every discovery we've uncovered in this journey, those cylinders of impossible alloy, the waves of ancient navigators, the whispering temples, the healing stones, points to one repeating truth. Our ancestors weren't behind us on some linear road. They were beside us on another branch of the same tree, reaching toward the same light we still chase. Every fragment of their world hums with that echo. We keep labeling it mystery, but maybe it's recognition. A reminder of what humans are capable of when understanding and wonder walk together. Think of it, each civilization speaking a dialect of the same language of pattern. The Minoans measured stars, the Persians taught water to move, the Maya turned architecture into calendars, the Egyptians fused hue with physics. None of them called their work science, yet it was. They absorbed knowledge through devotion and practice until the boundary between builder and structure disappeared. That's what modernity forgot, that intelligence thrives in humility. They didn't master nature, they listened to it. We call their feats miraculous because they feel unreachable. But miracles are just mastery filtered through time. The Antikythera mechanism wasn't magic, it was documentation of continuity. Human insight condensed into gears, meant to remind us that memory itself is technology. Those fragments whisper through corrosion, we solved this once before. There's an image that keeps resurfacing whenever you look at these ruins, a craftsman carving stone beneath the stars. Every strike echoes across centuries, still audible in data we measure anew. Maybe the real genius of antiquity wasn't invention, but intention, the belief that what they built should outlast themselves. They weren't chasing comfort, they were chasing permanence. And because of that, we still find pieces of them whispering back. For all our satellites and algorithms, we still can't reproduce some of their results with the same elegance. We imitate function but lose poetry. They built in harmony, we build in haste. Yet the fact that we're curious enough to study them means the conversation between ages continues. Discovery doesn't end, it reverberates. So if there's an echo through time, it's not of tools scraping stone. It's of minds remembering their potential. Each structure, pigment, and mechanism is a stored frequency of genius waiting for resonance. When we match it, inspiration feels sudden, but it's really synchronization, our neurons tuning to an ancient rhythm that never stopped playing. Maybe that's what progress truly is, remembering what we forgot and carrying it forward with fresh eyes. The people who built pyramids aligned to stars, who mapped oceans without compasses, who mixed colors that still glow, those weren't outliers. They were previews of us at our best. Proof that curiosity is older than civilization and stronger than collapse. The greatest lost technology wasn't buried under stone or erased in fire. It was our memory of how limitless we once were. And every relic we uncover is the universe nudging us to remember that again. If you want to see where that trail leads next, beneath the ice, into the secrets still frozen under continents we barely explore, stay curious. Because what's buried under Antarctica might challenge every limit we think we've defined. Subscribe and let's keep listening to the echoes together.